Okay, so thank you very much for the invitation, Manuel, and hello, everybody. I can't see you, but I hope that everybody can see me. So that's the title, as Manuel already announced. And I would like to start with lunar rhythms in animals. And you may know that many animals reproduce themselves in a kind of lunar cycle, so in synchrony with the moon. And here you see one of my favorite subjects. I did not study it, but it's very well known in the literature. That's a palolo worm that lives in the Pacific Ocean. And these worms reproduce once per year. And they do so by filling their hind ends with sperm and eggs. And then, very timed, just in autumn, during the last moon quarter at midnight, they just release the hind eggs. So they then swim up to the surface of the water, then they open and sperms and eggs are free and fertilization can occur. And it's very clear that this has to be very synchronized so that fertilization can occur. Other examples are corals that also release their gonads synchronously once a year, shortly after full moon. And maybe you heard about these land crabs on the Christmas Islands that migrate once per year to their breeding sites, and again, it's in synchrony with the moon. Otherwise, they live on land, but then once per year, they really migrate. So you see, it's not only lunar timing, it's also annual timing. And we have more examples. So for example, mayflies that live in lakes, and they can emerge several times per year, but always synchronously around the full moon. And then they mate, lay eggs, and die. And when they die, sometimes the floor, so the ground, and also cars are really covered with with these dead animals. So it's very oppressive if you live in these regions. Another example are chironomids. They emerge synchronously from the Lake Victoria, and this time it's not around full moon, but it's around new moon. And if you now think it's only invertebrates, this is not true. So a more recent study showed that even in petals, there is a synchrony with the moon. So here what I show is that calving frequency is highest during new moon or full moon, but that's not all. So these cows are usually fertilized, not anymore directly, but just, now I missed the word. So everything is done artificially, but nevertheless, when you look at the fertilization success, this was also highest either around full or new moon. And if you go to more closely relatives, here we have monkeys, so macaques, and they live outdoors, that is close to India in this case. And here you see the hormones that were measured in a single female macaque. And here is the time of the year. So what you see, that they show surges in luteinization, luteinizing hormone, follicle stimulating hormone, and also progesterone and estradiol during a certain season. So here it's autumn, it's November to March, so over the winter. And then they show nothing. But during that time, you see that again, this is very much correlated in this time, in this case, close or before the new moon. And in larger monkeys like gorillas, it's very similar. So they are not here it's not seasonally timed, but ovulation occurs around the entire year. And here you see the record of a progesterone metabolite. So it was collected from the feces of a single female around one entire year. And here probably the female was pregnant, but then afterwards she did not get pregnant immediately. And you see these monthly surges in progesterone metabolites. And when you compare it with the moon cycle, it always happens around the full moon. And amazingly, when you look at the mating times, this was also quite timed just before the ovulation of the female occurred. Not every cycle, but in many cycles. Okay, so these are some examples from animals, and of course what interests us a lot is what happens in humans. So in humans, there are older reports, but also the ovulation is synchronized to the moon. So for example, in the 80s, Kudla et al. Showed that in a cohort of American students, ovulation occurred predominantly around the new moon, but I have to say only in women who had a cycle length that was close to the lunar months. And if it was too far away, they did not see it. Another study that was carried out in Chinese students found that the ovulation occurred mainly around the full moon. And here we did no selection for a certain cycle length. But I also have to say that other studies found no correlation of the female cycle with the moon. Finally, let's go to sleep. And I know that many of you are interested in sleep. So Christian Kajochen found in 2013 that indeed sleep, the depth of sleep, but also the time of sleep, the time to fall asleep is strongly correlated with the moon cycle. And this study was done in the laboratory, and the probants were there for other reasons, so nobody was thinking about the moon, but retrospectively, they analyzed whether there was any correlation with the moon cycle. And these people who were in the sleep lab did not see at all the moon. So in the sleep lab, it was constant dark. And nevertheless, they found this correlation. So here you see all the probants, and it's very noisy, but nevertheless, when you just make an average, you see that the time you need to fall asleep was higher during the full moon. And here are other parameters. Here again, I think REM sleep latency, that's very similar to this. But you see also that the subjective sleep quality was lowest at full moon. The total sleep time was lowest at full moon. The deep slow wave sleep was lowest at full moon, and also the delta activity and also melatonin, that is very important for sleep, was lowest during bed. And finally, some years, 4 years ago, two papers, again about sleep, that was done in the lab of Horacio de la Iglesia. And he found exactly the same as Christian Kajochen, but he studied native Argentinians who had either little access or no access at all to electrical light. And amazingly, he found exactly the same also in a student group living in Seattle. And in Seattle, of course, you have a lot of artificial light and cannot see the moon. But nevertheless, the sleep onset was the latest some days before the full moon. So here you see the full moon cycle, full moon, here is new moon, and there is an accumulation of late sleep onsets before the full moon, but you also see a second smaller peak before the new moon. And amazingly, this is a study from my lab, we found the same correlation with the full moon, but in this case, it was about the menstrual cycle. And we measured the first day of the menstrual cycle. And you see, it's very similar. It's before the full moon where most of these onset of menstruation occurred, but there's a second peak before the new moon. So that was somehow amazing. But I have to say, we studied only 22 women, so that was not really enough. And this relation between the menstrual cycle and the moon remains still up to date controversial. So there were two big studies published in 2019 and 2021 who analyzed really many menses onsets. In this case, it was 7.5 million menses onset, and it was gained via smartphone apps. In this case, the app was Clue, and in this case, it was Lunar. Here it was a little bit different. 529 women were analyzed, and always the last 6 cycles in their period. And both studies could not find any correlation to the moon. However, there's another study that appeared last year, and this study also analyzed menstrual cycles of many women, so 35,940 women, again young women. But the big difference to this study was that these were recorded in the last century, so between 1940 and 1990. And they found a weak but significant synchronization to the moon. So what's the difference? So these are actual data from this century after 2010, and these are old data. But that's not all what is not clear. It's also completely unclear whether humans possess at all an endogenous or internal circulunar clock. So for those who are not working in clocks, I probably have to explain what is a circulunar clock. Perhaps you know a circadian clock, and for a circulunar clock, it's quite similar. So if it's indeed an internal clock, this circulunar clock should continue in the absence of environmental zeitgebers. And then it does so with its own endogenous period, and this is usually slightly different from the period of the lunar cycle. Another criterion is that the period should be temperature compensated. What does it mean? It should be independent of the environmental temperature. This is a characteristic that was developed for circadian clocks. But I have to say, if we go to mammals and humans, of course, this temperature is not so important because we are homeothermic, so we keep the temperature constant. So I think this is perhaps not the right thing we should look at. But there is another thing. If there is indeed an internal clock, it will be not possible to synchronize this clock. We entrain the clock to every possible cycle, because an internal clock can only entrain to a cycle that is not too far from the endogenous period. And we call this also that it has a limited entrainment range. So you may easily see that it is impossible to record menstrual cycles for years in women in constant conditions without any environmental zeitgebers. This is also not possible, and the entrainment we will see. However, we know that many animals indeed possess these circulunar clocks, and this was especially shown for the marine bristleworm Platinaris dumerili. They have this circulunar clock, and we know that because you can keep these animals in the lab and they reproduce in a lunar rhythm, and this lunar rhythm that fulfills all these criteria that I say here. Okay, now let's go to humans, back to humans and to menstrual cycles. And we had a kind of longitudinal approach to address all the questions I mentioned before. So we investigated the menstrual cycles of 176 individual women, and we took only cycles that were longer than 2 years. And the longest cycle that was recorded was 37 years. So how was it recorded? Actually, it all came from women that just noted the first day of their menstrual cycle in a calendar or on a phone app or wherever. And they didn't do it for the purpose of knowing whether it's synchronized to the moon. But they learned about my interest, and so they sent me these data. And then I plotted the data in relation to the moon. And we did also something special, because we did not only look at full moon and new moon cycles, but at other lunar cycles that are called anomalistic and tropical months. So the full moon, new moon cycle is a synodic month. I think that most of you are not familiar with these new lunar cycles, so I will try to explain it. So here you see a cartoon of Sun, Earth, of course not to scale, and here's our moon. And we all know that the Earth is rotating around the Sun, and for one rotation it needs 365.7 0.25 days, so not exactly 365 days, and that's the reason why we have to insert a leap year every 4 years. Okay, the moon orbits the Earth and it needs 27.32 days for one orbit. Then the Earth, of course, rotates, and again, this period is close to 24 hours. And here you see the situation of full moon when the moon is at this place because it's fully illuminated by the sun. This is new moon, and here we have half moon. So now perhaps you may think it should need exactly these 27.32 days between full and new moon, but that's not true. A synodic month, so the full moon, new moon cycle, lasts 29.53 days. And this is because that the moon is again on the opposite side of the sun. The Earth has, of course, the Earth after 1 month is about here. That means that the moon has to go a little bit further, maybe until this place, until it's again full moon. And this is the reason why this cycle lasts longer. I hope it's clear. So this synodic month affects, of course, nocturnal illuminance, but in addition, it also affects gravitation. And this can be seen in the tides on Earth. Always when the moon is in line with the Earth and the sun, we have either full moon or new moon. And then the gravitational forces of all three add to each other, so we have spring tides. However, when it's in this place here, we have neap tides. Okay, that's the synodic cycle. The next cycle is the anomalistic cycle. It comes about because the moon is on an elliptic orbit around the Earth, and sometimes it's far away from Earth and sometimes it's close to Earth. You see it also here. Again, we think this should last exactly the 27.32 days, but that's again not true because the entire rotation here also rotates around the Earth. So it takes a little bit longer. It's 27.55 days. And of course, this affects mainly gravitation, a little bit also the illumination because the moon is larger when it's closer to Earth. The last cycle, and this finally indeed has this 27.32 days, that affects again mainly gravitation, and it comes about because the orbit of the moon is tilted in relation to the ecliptic, and the ecliptic is the orbit of the Earth around the sun. So meaning that sometimes the moon is somehow below the ecliptic and sometimes it's up. So here it's up, here it's down, and this is exactly this period, and it affects also gravitation. So I hope this is more or less clear. At least the cycle is really complicated, and maybe you can appreciate it when you look here at the moon's appearance just during October 2007 in the Northern Hemisphere. So, but now let's come to the cycle. I told you that I got the data in calendars of menstrual onsets for many years. And I start with one example. So this was actually a 33-year recording, but I show only the last 21 years. And what you see is a kind of mensogram, and I try to explain what we did. So first of all, we repeat the moon cycles here on the x-axis 6 times. That means that we have here our new moon, that is full moon, new moon, and so on. And you see it's repeated 6 times. And the entire thing is plotted with the period of the synodic months. And therefore, now this is vertically aligned. What you see then is here in the horizontal lines, the lines are omitted for better clarity, that are just the different months. And here is 1 year, and in 1 year we have of course the 12 months, and we have about 12 times menstruation. And menstruation is shown as these black dots. So let's just start here. So the first month, the second month, the third, and so on. And what you can see that the period is quite long, meaning that this tree runs with a long period until here, and then it couples a little bit to the new moon. And then again, jump, and again the long period. Here it seems to couple again. Long period, here it seems to couple again to the new moon. Here again. And now we have to continue here to go on. Again a coupling, long free run, again a coupling, long free run. And here it is indeed around the full moon for more than 1 year. And then finally, this period becomes shorter than the synodic months. And here we see a coupling for almost 3 years to the full moon. And now it continues with a short period, couples again, and now the period is shorter and shorter. So we can now plot the same data also with the period of the tropical months. Now the maximal lunar standstill, oh, I forgot to mention it. So maximal lunar standstill is when the moon is up in the sky, and minimal lunar standstill when it's low in the sky. So they are now vertically arranged here. In addition, I also plotted the point of the closest distance of the moon to Earth, that's the perigee, and this is the largest distance from the moon to Earth, that's the apogee. They have a slightly longer period, and therefore you see running these lines here a little bit, not completely vertical. Okay, it looks chaotic because now the cycle of this woman is very irregular. That is because it's anyway very long. However, I think what you can recognize when it's cycling with the period of the synodic months, here it's also very regular, long period, of course. Okay, does it also synchronize to the tropical months or the anomalistic months? I think yes, perhaps not precisely, but here is a period where it always occurs before minimal lunar standstill. It's not so precise, but the period our paradogon analysis revealed that's indeed this period. When we now combine all the menstrual cycle of this woman, these were during the entire life 337 cycles, and we plotted according to the moon. So that's the same thing that I have shown before for entire population, just for this woman. And here we plotted to full moon and new moon. So here's full moon, here's new moon. And what you can see, there's an accumulation before the full moon and before the new moon. So it is indeed, this distribution is significantly different from a uniform distribution, and it's clustered around full moon and new moon. Here you see always the p-value for a peak distribution, so it was highly significant. That is the number of menses included. And here is the vector length. So that is an indication of the peak, of how peak the distribution is. The higher this value, and if it's above 0.1, it's really very peaked, when I just indicated as red. When we look at the anomalistic months, so in this woman, we don't see anything that is different from a uniform distribution, so not significant, not peaked. However, at the tropical months, I hope that you see again, there is a kind of clustering. It is before the minimum lunar standstill, and it was significant. It's not so much peaked, but at least it was significantly different from a uniform distribution. Let me show a second example. So I chose a woman who recorded the menstrual cycles for 27 years. And again, I show only the first 21 years. And I chose an example where from the beginning, the cycle period is shorter than these 29.53 days. So therefore, it goes into this direction. And you can easily see that here, a synchronization to the new moon, in this case, is only quite after the birth. There is a birth of a child, and here's a second child. And just in between, this menstrual cycle was synchronized to the new moon. However, there is a second period. It's not very nice, but here is a kind of synchronization to the full moon. So again, I can indicate it as that. Now let's look at the tropical and anomalistic cycle. Let's start with the anomalistic cycle. So that's perigee and apogee. And here you see that indeed there is a kind of coupling to the apogee for several, I think it's 3 years about. And then again, we see something now before the perigee here and here again. And this time it was even in synchrony with the tropical months. So here close to maximal lunar standstill. Here it's after minimal lunar standstill. Here it's very close to minimal lunar standstill. Here it's again close or at maximal lunar standstill here again. And if we now plot the menses, all the menses of this woman as a circular plot for the synodic, the anomalistic, and the tropical months, I hope that you can see that we find indeed a significant distribution here towards before the new moon, very close to apogee, and also after minimal lunar standstill. So this woman seems to be synchronized, but only temporarily, to all 3 lunar cycles. Okay, next thing what we did, we just pooled all data from all 176 women. And we did it first, again, as a circular plot for the synodic months, for the anomalistic months, and the tropical months. And I think here you can see that there is a kind of peak distribution, that it was significantly different from a uniform distribution. So here you see the number of women included, and here the number of menses. Of course, it's a lot now. It's peaked, but it's not greatly peaked, to be honest. And when we look at the anomalistic and tropical months, it was again significant, but not very much peaked. So you almost don't see that it's different. But our statistics says, yes, it is different from a uniform distribution. So our conclusion can be that the lunar cycles can, or better to say, the menses can indeed synchronize to the lunar cycles, but for sure they are very weak zeitgebers for the human reproduction. And if you compare the 3 lunar months, for sure the synodic months is the strongest, but obviously also the gravimetric cycle, so the anomalistic and the tropical cycles contribute. However, at the beginning, I have shown our initial study with the 22 women, and there the distribution to the synodic months was much more peaked. And here it was not anymore so peaked. And I show you this. So this is again the data from the actual study with the 176 women. And if I now switch to the old study, only 22 women, and you see it's much more peaked. And that's, you can also see in this value as. Back again, not so much peaked. In former times, very much peaked. So there was very little difference in the anomalistic months, in the tropical months. Here I show only the one from the new data, but the old data was quite similar. Now the question is, why we have this difference between our new study, including more women, and the old study? Perhaps you have already an idea. The difference was that the old study was collected in the last century, and the new study spanned the last and the new century. And what really changed during this time was light pollution. So here you see measured from satellite, light emitted from Earth in 2010, and in former times 192, sorry, 1992. I think it's quite impressive, the change. And I found one satellite picture from 2020, and it has even more increased. Also, you cannot completely compare this picture with the old pictures because it was a different satellite. Okay, without doubt, light pollution has increased. And of course, I wanted now to analyze it somehow at a certain point when it decreased very much. But what is this point? So I was lucky I found a publication about the power emitted and registered by satellites, and the measurements started around 1990, I think, and it went on until 1970 or 80. And you see there's already a blue arrow, and that indicates the time when powerful LEDs came on the market, and they replaced continuously conventional light bulbs. And this is true for indoor and outdoor publications. And there are different LEDs, of course, different temperature, but nevertheless, this is how the power of light increased. So I decided to take this point and analyze the data before 2010 and after 2010. And here you see the result. So this is the same data, but only the data that was collected before 2010, and this is after 2010. And again, you see here the synodic months, the anomalistic and the tropical months. I think these two are not as interesting, but this is very striking. So indeed, in this data, before 2010, I had a really peak distribution bimodal with before an accumulation before the full moon and before the new moon, but this was more pronounced. And amazingly, after 2010, there is no peak distribution at all. It's not significantly different from a unimodal distribution, uniform distribution, sorry. Okay, I have to say that also to the anomalistic and the tropical months, the synchronization was better before 2010. So for example, it was completely lost in the anomalistic months, but here it was still significant. So I think it's not as strikingly different as this here. So I conclude that a likely reason for the lost synchronization is light pollution, so artificial light at night alarm. So after I saw these data, I was thinking, are there any differences in synchronization between regions with high ALAN and lower ALAN? And when we look at the map, we can see that indeed there are regions where we have a lot of light, for example, here in the Netherlands, but also in North Italy. Here it's just color-coded and you see exactly the same. And I have to say that the data I collected were mainly stemming from women living in Italy, mostly North Italy, and in Germany, from Germany. So I thought, okay, I compared the German with the Italian data, and did not work. What's now? Okay. And I plot only the synodic months, of course. So this is the German and this is the Italian data. And I think you can easily see that indeed in the German data there was a more peak distribution than in the Italian data. I admit that this is, of course, not really very precise because we don't know to how much artificial light the women expose themselves indoors. It's only outdoors, but it's an interesting correlation. And there was something else that was quite striking because I found publications who investigated the effects of artificial light on the cycle lengths. And we realized that the cycle becomes shorter when women expose themselves, it was in an experiment, to artificial light. So this kind of light screens to improve the well-being during wintertime. And what they found, then the cycle of these women became shorter. So I looked at the period of these German and Italian women, and indeed I found that the Italian woman had a shorter period than the German woman. So that's 1 day difference in period. So that was interesting. So I conclude my second conclusion that artificial light at night appears to obscure the luminous cycles of the moon and shortens the period of the menstrual cycle and also impairs the synchronization. But what we also have to say that, of course, the purely gravimetric cycles on menstruation cycle, they persist in modern time. So the next question, what I asked, is the synchronization to the lunar cycle, to the synodic cycle, is higher at times when the gravimetric influences of the moon intensify the synodic cycle. And we have such times. we have it twice per year because every winter and summer solstices, that's the time of the longest day at the end of June and the shortest day at the end of December. They coincide with lunar standstills. So, and I indicated here. So in summer, we have always a new moon indicating this minimum lunar standstill. So here the moon is below the horizon. And in winter, we have the full moon coinciding with maximum lunar standstill, but here the moon is up the horizon. So we decided to look at our circular plots during 3 months during the winter solstice. So we took December and January and only looked at the 2 months. And we took also June and July, only looked at these 2 months. And here you see just the rest of the year. And again, you may see that during the winter solstice, the peak distribution it's really very peaked, whereas here it's not very different from the rest of the year. So next question, why in the winter and not in the summer? This took me some while, but when I realized that there is another thing that affects, of course, gravitation, and that is the relation of the Earth to the Sun, because our Earth is also on an elliptic orbit around the Sun. And always in January, it's closer to the Sun than in July. And again, we have here words for it. So this is a perihelion and this is an aphelion. Okay, perhaps this is really the reason for this better synchronization of the menstrual cycle to the synodic months in January, because here, of course, the gravitational forces of the Sun and the Moon add on these of the Earth. Okay, but of course, when you think about January, and I have to say that all my data from these women, they came from the Northern Hemisphere. So that is winter time. And in winter time, we have also dark, long nights, and you can see the moon much better. And I also heard that at that time, the moon is more intense. So the intensity is much better, higher than in summer. So maybe this is one of the reasons. So now, of course, we could not collect data from the Southern Hemisphere, but my Italian colleagues had an idea. So I thought, okay, we look at Google Trends and we look for the searches for some menstrual-related expressions. So for example, we looked at period pain. So we just looked how often people were searching for period pain throughout the entire year. And they did so in countries, several European countries, but also Australia, South Africa, and what was it, New Zealand too, in the Southern Hemisphere. And amazingly, what we found, and this was true for both the Northern and the Southern Hemisphere, that there was indeed a synchronized search for period pain during perihelion. So this, of course, suggests that the menstruation occurs somehow synchronously in many women during perihelion. We did not find any other correlation to the months throughout the entire year, and also not during July, so during the summer solstices. So, third conclusion, I think that human somehow can sense the gravimetric forces of the moon and the sun on Earth. Also, I have no clue how, but perhaps we can discuss about it. Last question. Do humans indeed possess a circulunar clock? I think it's likely because the menstrual cycle free runs already under normal Zeitgeber conditions, so normal days and nights and moonlight with its endogenous period, and it's only temporarily synchronized to the moon. So it has a kind of endogenous cycle period. And as I said in the beginning, it's very difficult to test this in the laboratory in women. So some people even suggest that we should test it in the orbit, but I think it's absolutely senseless to do this. However, what we could test whether there is a limited range of entrainment. And here you see again a cycle of a woman. Actually, it's not one woman. What I did, I just combined typical cycles for 4 women to show the characteristics of the cycle. Because what happens in every woman, that the cycle speeds up with age. So here it's very long, at the end it's very short. The other thing is, at the beginning it's also quite irregular. So that is just here's menopause, and here it's, okay, the term will, it's the beginning of the menstruation. The term will come, menarche. Yeah, so here it's long and irregular, and here it's short and irregular. And in between, we have this coupling to the synodic months. And actually, we found it at periods from about 36 days down to 26 days. So that is about here. And later, never ever. When we look at the anomalistic months, you see that the entrainment occurs later in life. But some women, of course, have already a short period at the beginning, so it occurs early in their lives. Also not very late. So here we found it from 31 days down to 24 days. And for the tropical cycle, it occurs when the period is again shorter. So it's here. So this shows us indeed the limit of entrainment for the 3 months. And what you easily can see, that the synodic months is the strongest zeitgeber, but nevertheless, it cannot, the cycle cannot anymore entrain if it's too far away from its the lunar cycle. So I hope this was clear, but please don't hesitate to ask at the end. And I'm close to the end. I just summarize. So I think that I can say that humans appear to possess a circadian clock that controls the female menstrual cycle. I think we cannot test it for sleep, but for the menstrual cycle, we can do it in these longitudinal records. Then I think that in ancient times, perhaps the menstrual cycle entrained to the synodic months. And ovulation occurred mainly around the new moon, or in rarer cases, but it also happens around the full moon. In modern times, artificial light at night seems to reduce the entrainment of the menstrual cycle with the synodic months by obscuring the moonlight and shortening the cycle duration. However, entrainment is still present when the gravitational forces of the moon and sun on Earth are high. And this is especially the case in December, January, during the winter solstice and perihelion. So I know that I cannot say anything about the effects on fertility. However, I think that these results could be relevant for human fertility, especially since the length of the menstrual cycle appears to be an age-dependent marker of female fertility, and it becomes shorter with age and with artificial light at night. And I just end with my acknowledgements. So I'm very thankful to my colleague Thomas Wehr, who is a psychiatrist and actually works on lunar effects on mood cycles, Oliver Mitesser and Thomas Hobestad, who did the entire statistics, and my Italian colleagues who helped to collect data from Italian women and also had participated in a lot of discussion and had the idea about Google Trends. So thank you very much. Manuel, shall I close the presentation, or how do we do it?
So you can maybe leave it open if there's anything you might want to refer to.
Good.
So we have a couple questions in the Q&A. Thank you, by the way, for a really, really nice talk. I love these data, and I think it's really, the visualizations are beautiful. The findings are super interesting. And, in particular, what I appreciate is I think the sort of methodology and the methodicalness that you use here really to, for example, establish, the kind of almost dose-response relationship with different levels of light pollution. So I'll go through the questions. We have one question from Lorraine Calcott, who says, Charlotte, by the way, if there's anyone in the audience who'd like to unmute, just raise your hand and I can ask to basically unmute you to ask the question. So Lorraine is saying, Charlotte, fascinating paper, really unique perspective. Can I ask you if you took if you took perimenopause and menopause into account, and if the body still remains synchronized with the moon in any way? I think you answered this in the second talk, harder to track, of course, but just wondering
Yes,
if this might explain some of the chaos the body feels at the time.
Yeah, absolutely. To be honest, so in my first study, I already realized that with increasing age, the probability to temporarily synchronize to the moon was really going down. And this was also the reason I forgot to say it, but in the second study, I took only data from women who recorded their menses before 35. And many of them have been really young, and I think from 9, I had the data from menarche onward. And this increased the likelihood to synchronize to the moon. Yeah.
Great. I think Lorraine also says the link with light pollution is quite significant and adds weight to the argument to reduce it. There's measures for ecology, but we rarely talk about the impact on humans and especially women. Very interesting research.
Thank you. And I think the light pollution, of course, has also a great impact on circadian rhythms. So probably much more than on this. So.
One question from Luis Busla. Very interesting findings. Have you considered extending your research to other planets of our solar system? For example, how do other planets and their position in relation to the Earth influence the human lunar plot and the menstrual clock and the menstrual cycle?
Actually, I thought so, but you know, there's also heavy criticism coming from certain physicists who think, and they are right, because if you measure gravitational influences on Earth, they are so tiny that we don't know how we can sense that all. If I now take into account the Mars or the Venus, I think then it will be so esoteric. So I thought, no, don't do it. So I got already comments from some people who said it's completely nonsense and it's close to astrology. So I don't think I will do it, but I think it's interesting because we found even more. We found even a relation of 18 years, the cycle of 18 years. And this has, of course, also to do mainly with the lunar cycle, but with the entire constellation, how far the moon is to the Earth, but also the sun correlated. So it's very difficult to explain. I think there's more in the data, but it's too difficult. So I think I don't want to go to other planets and include their influence.
Great, thank you. One question from Roderick Lambert. Fascinating. I missed the part, unfortunately, so maybe this was explained. But concerning artificial light at night, were you able to pass out outdoor from indoor light at night?
Yeah, I have no data on that. It would be very fascinating if these women would have recorded also their exposure to indoor light. But you know, they did record their own menstrual cycle only for their own interest. And I have no data on this. I just have the first day of menses onset. And I asked them where they live. And some women told me, okay, in a big city or in the countryside. But the next problem is women are, of course, mobile. So they don't stay in the same area all the time. So several of them moved to other regions. So this was too complicated. And so I did not really include it in the data.
Great. A question from Tobias Walter. Thanks a lot for the interesting talk. From an evolutionary perspective, it seems logical that we adjust our internal clock to the day-night cycle or light-dark rhythms. Do you also see evolutionary reasons, in quotation marks, for an internal moon clock? Or is it just because of physical reasons like gravity?
That is actually a very interesting question. Of course, I was asking myself, does it have any sense to time our ovulation to a certain period? And then I found this very interesting paper here. Of course, I replotted the data, so that are not the original data. But the interesting thing was actually that Horacio de la Iglesias group showed the sleep data, meaning that before the full moon, people go to sleep much, much later. Okay, why? The interesting thing is that during increasing moon, that is waxing moon, the moon already rises in the second half or even in the afternoon. So here we have the waxing moon, and you see the moon rises already at 12 somehow. And then it's up when it's going, when dusk sets in. So it's already light, okay? And then it goes down in the middle of the night. During full moon, the moon rises actually exactly more or less at dusk, if we take a 12-hour cycle, and then it vanishes again during the morning. However, waning moon means, and this is all the cycle from here to here, but the moon rises in the middle of the night, so it's dark when it starts. And this is also one of the reasons why the maximum is actually here and not here and not here. Because here we have the highest light already during dusk, okay? And then people go out, they play, they talk, and probably in former times, perhaps they even hunted or did something else, I don't know. However, here it's quite dangerous to go out because it's dark. And this study here just monitored the number of victims caused by lion attacks in Tanzania. So it was from 1988 to 2009. And lions hunt during dusk mainly, not only probably not predominantly humans, but also other animals. But the kills was highly significant higher during the waning moon than during the waxing moon. And this shows me that in this part of the cycle, it's better to stay at home and don't leave your homes, because we cannot see, but the lions and other predators can see us. And if you have to stay home, from the term of evolution, I think it's very useful then really to generate children. But there is a second point. And to say, if menses starts at the beginning here, then ovulation was here, okay? But you see there is also a maximum. And of course, the second possibility is that you go out during this time, have fun, perhaps find a partner, and afterwards you just generate children. So that's the second possibility, perhaps for the later, for the evening types, and here it's more for the morning types. I don't know, that would be another nice correlation. But I think that might be an explanation why our activity is also related to the moon.